Chapter 1, Lesson 9 on page 81. Today is called direct variation. Okay, when you think of the word variation, you can just think of the word change. And direct means like immediately or straight, right? So it's like immediate change or direct change. Okay? These are the words direct variation, constant of variation, constant of proportionality. Yes, these are big words, but don't worry. They're not as complicated as it sounds. We'll get through it. Okay. The distance, y, a car travels after x hours can be represented by y distance equals 65x. So that means 65 miles per however many hours. The table and graph also represent the situation. So 2 hours, distance is 130, 3 hours, 195, 4 hours, 260. And they've also graphed it 2 and 130, 3 and 195, and 4 and 260. Remember back in an earlier lesson, we talked about, is something proportional or not? Proportional or not? And we said that the test was if the line was straight, which it is, yes, and does it go through the origin, which yes. So this is a proportional relationship or a proportional graph. Okay, and if we look here, let's see, this is going up by 1 plus 1 plus 1. And this one's going up by, well, let's think about it. Fill in the blanks to find the constant ratio. So this is the distance traveled over the driving time. Okay, 195 up to 3 and 4 to 260. I just got this information right here. The constant ratio is blank miles per hour. You can think of it as the unit rate, the constant rate of change, or slope. We've learned all three of these, and they're basically all the same. Okay, think about it. Find the unit rate. Well, to do that, we just have to do 130 over 2, right? And we want to get to 1. So divide by 2, divide by 2. Man, running out of room, but if you think 130 divided by 2, $65. Okay, so the constant ratio is 65 miles for 1 hour, which is the unit rate, and it's also the constant rate of change, or the slope. Remember, slope meant you take any 2 points. So they've taken 3 and 195 and 3 and 195 and 2 and 130. You subtract the y's. Basically, you're finding this information here, okay, which is going to be 65. And you subtract the x's, which is 1. See how the slope is the same as the unit rate and same as the constant rate of change. Okay, these are basically all different ways to say almost the same thing. Write a sentence that compares the constant rate of change and the constant ratio. Let's see. When the quantities, that means like numbers, are proportional, then the rate of change and the constant ratio are the same. They didn't give us much room there, did they? When the quantities are proportional, then the rate of change and the constant ratio are the same. Okay? All right, so let's keep going. see what they mean. This is a bit of a long lesson. Just try to hang in there. Pay attention as much as you can. Yeah, that way you won't be lost in class. Okay, a linear relationship is a direct variation when the ratio of y to x is a constant, k. So k is the constant. It means it doesn't change. Doesn't change. K doesn't change. We say y varies or changes directly with x. Okay, so for example here, the y value and the x value. Okay, so they're saying, example, if y equals 2x, right? So however many x is, and then 2 times that to be y. So this would be an example. Okay, so y equals kx. Okay. Says, when two variable quantities have a constant ratio, the relationship is called a direct variation. The constant ratio is called the constant of variation, and the constant variation is also known as the constant of proportionality. So you're going to see these words throughout the lesson. In a direct variation equation, the constant rate of change, or slope, is the special variable k. So they're going to use the letter k. All right? So let's look at example 1. Don't worry, it's not as hard as it's sounding. The height of the water as a pool is being filled is shown in the graph. Determine the rate in inches per minute. Okay, so here's the time, and it was filled 2 inches. 10 minutes, we had 4 inches, and so on. Since the graph of the data forms a line, okay, it's proportional, and it goes through the origin, remember? Has to go through 0, 0. Okay, then we know this is proportional. And what's the rate of change? Well, it's going, let's look from this one. It's going from 10/4 to 5/6. So the x value and the y value. So if we do the slope, it'd be the y value minus right here. Here, I'll highlight it. This y value over the change in the x value. X value and x value. So 15 minus 10, which 6 minus 4 is 2. 15 minus 10 is 5. Okay, so the slope would be 2/5, but let's put that in simplest form, and they've done that here. They've put it in decimal form, right? 2/5 is the same as 4/10, which is a decimal is 0.4/1. So the pool fills at a rate of 0.4 inches every minute. Okay, so let's check. Got it, okay? 2 minutes after a diver enters the water, he has descended 52 feet. So the first thing you want to do, write that down. 2 minutes, 52 feet. Okay, after 5 minutes, he's gone 130 feet. At what rate is a scuba diver descending? So for me, I'd want to find the unit rate, right? If this was a graph, right, we'd have 1 minute, 2 minute, 3 minute, 4 minute, 5 minute. I want to know the unit rate. Okay, so divide by 2. 52 divided by 2 is 26. Okay, so now we know 1 minute, 26 feet. At what rate is the scuba diver descending? 1 minute for 26 feet. So 26 feet per minute. Does that make sense? Okay, so first thing you do is write the ratio, same style as we've been doing. Okay, then find the missing value. All right. The equation y equals 10x represents the amount of money y Julio earns for x hours of work. Identify the constant of proportionality. Explain what it represents. Well, so this would be y, how much he earns for x hours of work, and 10 would be the amount of money he's making, right? Because if this x was 1 hour, then he would be making $10, right? If the x was 2, then he would be making $20. So $10 over 1 hour, right? That's the unit rate. So the constant of proportionality is 10. This is the constant, 10. So look at this one. The distance y traveled in miles for the Chang family in x hours was represented by the equation y equals 55x. What's the constant of proportionality? Okay, so what is a thing that is being multiplied by? So put your answer here in B. Not all situations with a constant rate of change are proportional. Okay, so sometimes things aren't proportional, so you have to be tricky. Look here, it's a straight line, but if we extend this line, does it go through the origin? No, it does not. Why? Well, let's look at the problem. Plus a delivery charge. So this is throwing you off, right? The delivery charge is added on every time. So that is making it not proportional. There's no constant ratio. The line does not go through the origin. So this is not a direct variation. This is not a proportional relationship. So be careful. Okay, 2 pounds of cheese costs $8.40. Okay, so first thing I'm going to do, 2 pounds of cheese, $8.40. Show the cost of 1, of 2, of 3, and of 4 pounds of cheese. Okay, well, 1 pound of cheese, I have to just divide it in half, which will be $4.20, right? So this is your constant. So now give the value if there's 3 pounds, if there's 4 pounds, okay? So on C, you need to give the answer for 3 pounds and the answer for 4 pounds. LB means pounds. That's just the shortened version. So give these 2 answers right here. Okay, you should have answers in class, especially just in case your popsicle stick gets called. Okay, last example. Determine whether the linear relationship, linear means line, is a direct variation. If so, state the constant of proportionality. Well, first thing we got to do, let's see. Going up by 1, going up by 12, 12, 12. Okay, good. So unit rate is 12. Okay? Compare the ratios. Yep. They all have the same simplest form. So they are proportional. They're proportional. And what's the constant? Well, the constant is 12 over 1, or 1 over 12. It's going up by $12 per X hours. Okay, great. Now for our drawing today, I have looked up how to draw a cute little bear. I don't know why, it just came to my mind that I wanted to draw a little bear. So I looked up how to draw a cute little sketch by sketch bear. Okay, so draw the head, then you draw the ears, and then to give some dimension to the ears, you draw an inner line. Okay, then you can draw like little eyes, and a little nose. And they said kind of like make these little wingtips coming off, and then make a little circle around. Okay, now they said make a little swirly. This is going to be the arms. A little swirly. And then we'll make him like he's like looking over a desk or something like that. Aw, isn't he adorable? All right, I will see you in class.